type of MRI stuff, where firstly why anaesthetists involved with MRI scanning. I took this off the AAGBI guidelines for MRIs, and we were there to facilitate good imaging, because you've got to be really still for the MRI, by keeping a patient still, keeping them safe. It's a bit of an isolated site often, and with limited access to the airway when the patients are within the MRI scanner, because they're in a magnet but also constrained physically, and multiple issues relating to the magnetic field. So I try to cover like each aspect of this for this presentation. And typical patients that we're involved with would be patients who can't lie still. So for example, if they've got movement disorders, if they're particularly young, with learning disabilities or severe claustrophobia adults, in intensive care, and probably not in East Sussex. Sometimes we have intraoperative MRI scanning as well. Fine. Back to A-level physics. Does anyone want to volunteer how MRI works?
You effectively need to align the spins of the protons, and then effectively you make them all flip by shooting a radio wave at them, and then when they flip back their original or their ground state, they release energy, and then that wave of energy is effectively collected or measured or sensed, and that effectively gives you an image, something along those lines.
Yeah, that's pretty much, that's a pretty good summary of it. So MRI, non-ionizing radiation, this is just general information. There's a static magnetic field, and it relies on the interaction between that and the atomic nuclei, and it's an extremely strong magnetic field because it's 0.5 to 3 Tesla, and the Earth's magnetic field is 10,000 times less than that, relative to MRI. And as Oscar was saying, it uses the hydrogen nuclei, so H plus, so protons. They have got an intrinsic spin, so it spins around its own axis, and forms a magnetic dipole. When you put it in the static magnetic field of the MRI, all the protons align their spin in the same direction, and then the radio frequency pulse, which comes at right angles to the spin, and it causes the protons to be displaced, to wobble and precess. So if you can imagine this as the diagram in the bottom right says, it sort of wobbles around like a spinning top like that around its central axis. So it precesses around the central axis, which is there. Does the red thing come up, by the way?
Yes.
Okay, fine. There we are. And then the precession of the wobble decays, and when it decays, it releases energy, and that the electromagnetic waves, when it decays, is detected by the MRI scanner, hence forming the images. So this is kind of like a visual representation of this. The radio frequency pulse is given this way when all the original axes are aligned that way, and then it starts. It flips into a slightly different angle, and then they eventually decay. So it goes from there to there, and then eventually it decays to go back to the original alignment. And when it decays, in terms of its spin, it releases energy. The energy is detected, and and images are formed from that. We might have heard of T1 and T2 weighted imaging. Do any of you want to make a hazard about what T1 and T2 is or does?
I mean, the result is the brightness of water in each scan, and I just know that T2 is the water is white on a T2 because it's the same as the in T2 the film Terminator 2. Arnold Schwarzenegger is good, so it's on the white, so that's how I remember that. Hopefully that's right, not wrong, but
it's to do with the way what it's measuring. I remember learning this, but I've not forgotten. It's to do with the way it comes back and the type of decay that you're measuring. If one is T1 and one is T2, but I can't remember the specifics of it.
Yeah, they're basically what's this? T1 and T2 are relaxant, like different time constants, which for that relaxation as previously described, and they measure slightly different things. Functionally, T1 identifies gray-white matter contrast because each different tissues have different T1 times, and T2, as Cav appropriately says, is water is bright and it can identify a edematous tissue. Yeah.